In this video, we're going to be looking at identifying the number of protons, neutrons, and electrons. Some things for you to keep in mind: that your atomic number is going to be equal to the number of protons in the atom. If we have an atom and not an ion, in an atom, the number of protons will be equal to the number of electrons. And in order to find the number of neutrons, it's going to be your mass number minus your atomic number, remembering that the atomic number tells us how many protons are in an atom. I want to make sure that I review with you the different ways to distinguish between isotopes. This method is called the nuclear symbol. This is the hyphen notation. Actually, both of these are hyphen notation. This hyphen notation uses the name, where this hyphen notation uses the symbol. Okay, so taking a look at our first example. So if you look at the periodic table, when you look at the average atomic mass of lithium, you'll see that lithium has an average atomic mass of 6.94. That is the average atomic mass of all of the isotopes of lithium. All right, so right here, though, I'm looking at two different isotopes of lithium. This is lithium 7 and this is lithium 6. All right, and since they're both isotopes of lithium, they both have an atomic number of 3. Therefore, they have 3 protons. This is an atom of lithium, and we know that this is an atom because there's no charge here. So since this is an atom, if there are 3 protons, there are also 3 electrons, because the number of protons and electrons in an atom are equal. You have 3 positive charges and 3 negative charges. Now, to find the number of neutrons, if you look earlier in the video, to find the number of neutrons, it is your mass number minus the atomic number. So 7 minus 3 equals 4. All right? Remembering that the mass number minus the atomic number, and your atomic number is always equal to the number of protons. So 7 minus 3 equals 4. Looking at lithium 6. Lithium 6 has a mass number of 6, still with 3 protons. 6 minus 6 equals, 6 minus 3 equals 3. So here I have identified the number of protons, neutrons, and electrons for lithium 7 and lithium 6. Yes, as a reminder, I know that lithium, when you look at the periodic table, has an average atomic mass rounded to the nearest whole number of 7. However, this right here lets us know that we have an isotope of lithium. Okay, so here is another example of how to calculate the isotopes of an atom. Right here, the example is oxygen 16, oxygen 17. Oxygen 16 has a mass number of 16. Oxygen 17 has a mass number of 17. Looking at the periodic table, oxygen has an atomic number of 8. Since oxygen has an atomic number of 8, we know that there are 8 protons for both isotopes. And because we have an atom, we know that the number of protons and electrons are equal. So oxygen 16 has 8 electrons. Oxygen 17 has 8 electrons. To find the number of neutrons, it is your mass number minus the atomic number. 16 minus 8 equals 8. And 17 minus 8 equals 9. Okay, here's our example. Again, to find the number of neutrons, it is your mass number minus the atomic number. The atomic number for oxygen is 8. So there are 8 protons for each isotope. Because it's an atom, there are 8 electrons, because you have an equal number of positive and negative charges in an atom. To find the number of neutrons, it is your mass number minus the atomic number. So 16 minus 8 equals 8. 17 minus 8 equals 9. All right, so I want to make sure you know how to distinguish between isotopes. So right here I have a made-up element. It is element X that has an atomic number of 21. Remembering from your notes previously, go back and review that isotopes are atoms of the same element that have the same number of protons, but they have a different number of neutrons. So if they have a different number of neutrons, then their mass number must be different. If they have the same number of protons, then the atomic number must be the same. So looking at this example, which ones have the same atomic number but different mass numbers? You're looking at X41 and X42. This particular one is not an isotope because the atomic number is different. In order for them to be isotopes of the same element, the atomic numbers must be the same.